Hi there, Physics 131. This is just a real quick video to go through the reading for today, class 11, which is just section 4.4, skills for analyzing processes involving forces in two dimensions. And so it goes through this whole problem-solving strategy and works through examples in detail. So I really encourage you to kind of go through this, but also try to write things down in your own way on a piece of paper so that you get an idea of how you want to do this. But you're always going to make a sketch of the process, choose a system, choose coordinate axes, identify the unknowns and knowns. So here's an example of a sled. You've got a normal force, you've got gravity acting down, and now there's this tension which is at an angle. And what will tend to happen is that you'll end up with these equations like the horizontal x component of Newton's second law. M times a sub x equals the sum of all the forces in the x direction. And in this case, there is no, I guess the normal force, this says cos theta here, cos 90. So the normal force is 0 in the x direction. And in fact, gravity, is another cos 90 here, is 0 in the x direction. So all you have is this component, cos times 37 times the tension, which gives you the x component of the tension. Okay. And then sometimes once you've got the acceleration, you can use kinematics equations to solve for velocity. So look at that example. There's some stuff about how you use your equations, how you set things up. There's that, again, that the sled example. Was the car speeding? So here's an example where there's kinetic friction because the car is sliding along, and you've got normal and gravity. So the y component equation tends to give that the normal force is equal to mg, a lot of the times. And then you use the x component equation to find the acceleration in the x direction. And then you can use kinematics equations to solve out things like how far it goes. With inclines, the big trick that happens here a lot is that if you've got acceleration going along an incline, you tilt your axes to match the incline. So x is the direction that things can accelerate in, and y is perpendicular to the incline, and there's no motion in that direction. So that when you do your represent mathematically, at some point often, the a sub x equations will give you the acceleration, and then often what will happen is a sub y will be 0, and so that's how you can solve things out for normal force. So go through that, and then I think lastly it talks about pulleys and this Atwood machine. So you've got two boxes, M1 and M2. They have the same magnitude of acceleration, but they're always in opposite directions because they're connected over this pulley. And what you do in all these problems is you first choose a system and draw the force diagram for that system. So if there's two blocks, there's two systems, you need two force diagrams, and you end up with two sets of equations. So again, get used to doing that, writing down x components, writing down y components, and solving out for what you need. So I think in this case, often what happens is that there ends up being two equations and two unknowns, where the unknowns are the tension and the acceleration. I think they end up solving out for the acceleration. So once again, I really encourage you to take a piece of paper, blank paper, kind of work through the examples on your own so you kind of get a feel for how this goes. And then of course, try the problem set and try the questions on your own so that you get more confident in solving these problems on your own, like you're going to have to do when you get to the tests. Okay, bye for now.